Hello, on behalf of TAS International, I'd like to welcome you. My name is Peter Rittmeyer, and this topic we're going to talk about output. It's a small chapter, but I think it's one of the most important ones, because setting up your model is one, but then you need to check whether the results are as expected. Of course, you can look to your kinematics, and that's one, but signals can be pretty important, especially if you have something to compare with experiments, or if you would like to analyze the load path into your system. In this part of the presentation, we're only going to focus on multi-body system output. Obviously, there's more output like FE, or more general output like energy. Energy is a good way to check the correctness of your solution. In this case, we're going to focus on multi-body system. In this slide, you see an overview of some typical output that is used. Most dummies do contain them all. But as a user, you can also specify your own output if you like. Output body, often used to measure accelerations. Output body LL can be used for displacements. In a dummy, it's often used for chest deflection. Body state can be used for power analysis. Joint off provides you information about the joint displacements, rotations, velocities, etc. And joint constraint, those are the degrees of freedom of a joint that are suppressed. Those outputs, so forces and torques, can be found in the joint constraint output. The restraint, for example, if you have a hinge of a door which has a torque spring in it, those output can be requested by output restraint. And there is another one, output system COG, which provides you with data of the center of gravity of a whole system, or even more systems if you like. There's even more output available, but a few of them we're going to discuss in this presentation. The first one is output body. It provides you with information about linear or angular displacements, velocities, accelerations. You can define it, with, for example, with respect to reference space, but also with respect to a body. You can apply filtering. It might be that it is required because of regulations. Filters are often used to get rid of the high frequencies. Extended sampling probably requires a little bit more of attention, as this is a complicated one. It's by default on. What does it mean? Your integration time step is typically a few orders smaller than the output you have defined. Suppose your simulation is running on 1 - 6 seconds. Your output time step is typically 1e - 4. So 2 orders difference. If you're going to filter on the output time step of the multi-body, you end up in aliasing effects. Basically, it means that the output time step is not able to filter off the high frequencies. And you can search on the internet on aliasing to find more detailed information about it. But basically what it does, extended sampling, it stores all the multi-body output time steps into a temporary directory. If you have long simulations, this directory can become pretty large. But after the simulation is done, this data is going to filtered by a low-pass filter, and that's basically what extended sampling is doing, before applying the user-defined filter. The last three, so the correct one, requires also a bit more attention. They are only applicable for linear accelerations. In the previous presentation about load applications, it is explained that if you have, for example, a frontal crash, you can apply the crash pulse on the vehicle. But you also can define an artificial acceleration field on the dummy by multiplying the acceleration pulse in the y direction by -1. If you don't correct for that, and in this case, in this example, you see that the corrects are off, but for the most dummies they are on, it means that if it's set to on, that this artificial acceleration field is subtracted from the total acceleration field. If you won't do this, you will probably experience much higher or much lower accelerations than expected. The next slide is output body rel. Pretty much similar as output body, but here you can focus on relative displacements. As I said, for example, the chest deflection of a dummy. But also if you have specified potential meters, we call them pot meters often, in a crash safety simulation or your experiment, you can define them with output body rel. Kinematic joint output has also multiple purposes. It provides you with position, velocity and acceleration data of the degrees of freedom of a joint. Also filtering and extended sampling are the same like the previous ones. Kinematic joint output is also used sometimes for pre-simulation. So suppose you have performing a settling run, your dummy is going to be positioned inside your seat and the floor. Then at the end of the settling simulation, you get the kinematic joint output data. Well, after this settling simulation, you would like to start a new simulation, which is the actual crash pulse simulation. Well, Xmagic facilitates to read in the joint output data, the positions of all the joints of a dummy, and such that the dummy is positioned automatically in the way it has ended in the simulation, in the pre-simulation. This is just for convenience. Of course, you can do it manually as well. Output joint constraint is, as said, the degrees of freedom of a joint that are suppressed. Basically, they follow the same concept as the other ones. For all those outputs, I recommend you to focus on the reference manual because it contains a lot of details in the way you would like to get your output. However, this is already the last slide, you can specify your output, but that doesn't necessarily mean you will get your output. Typically, the dummies contain a lot of output data, but you might not be interested in all of them. For that reason, you have to specify under the control output which output you would like to have. In this example, it's pretty straightforward because all the belts, body, etc., they are all switched to on. But you can tailor-made it in the way you would like to have it. So really specified output. However, in the beginning, when you're setting up your model, I do recommend to specify a lot of output data, because in that way you gain confidence in the quality of your model. That brings me to the end of this presentation. Goodbye.